of JAMOVI, and then we'll see how the JAMOVI interface works. So this first I'll show you what is this JAMOVI software, and what is the advantage of this software over the other software which are there with us. Like previously, generally all of us, we used to work on SPSS or on Strata, SAS. Most commonly, all of us were working on the SPSS. But with this advent of JAMOVI, this has made our life very simple. Actually, this JAMOVI, the language is the R language. So in the background, you will see that it is the R which is working. So this JAMOVI, this was released on August 2018. And since it is an open source software, so all the modules which you see, that gets an update periodically. So few functions, if you're seeing it now, maybe after a month or so, you will see that few more functions are getting added. So it is not something static, rather it is dynamic. Every time you will see the interface. Even when we conducted our first JAMOVI and now when we are conducting our fifth JAMOVI workshop, there are many options which has been added. So that's how you need to see it continuously. If you are working, you will come to know that these are the updates. So what we can do with this JAMOVI, that first is you can do the basic data analysis, which for which we have organized this workshop. In this 1.5 day, we will be entirely focusing on very basics of data analysis. Once you are through with those concepts, then you can build up your advanced skills. And advanced you can explore also, because if you have got theoretical background of the knowledge, you can just see the software and you can keep on exploring. The only hitch or the hurdle is the initial push. So we want to push you through those hurdles so that the later advanced one, even if you don't want to attend any workshop, you can build up your concepts. So for basic data analysis, this is a very good software. Yes, for advanced analysis, because you will see that once you download the JAMOVI, with the basic one, it has got all the basic analysis. But with the other advanced one, you need to install the modules. So those modules, we'll see how to install those modules, because for every analysis, like if you want to download do the survival analysis, you need to download the survival module. If you want to do the scale like factor analysis, you need to download those factor analysis module and so on. So for advanced data analysis, you need a module installation. And for meta-analysis, again, you need a module installation. So in running the analysis, whenever you do the analysis in the SPSS, those of you who have worked over the SPSS, you know that there are two windows. There's a data window and there is an output window. And in the data also, you will see there is a variable view and there is a data view. And output comes separately. And that output is also not dynamic, it is static. What do I mean by that? That we'll see here that if you in the JAMOVI, if you remove the variable, that output which is there, that also disappears. So that's maybe you can take it as an advantage or a disadvantage. For us, it is an advantage. Why? Because you don't need to scroll up and down to see what came earlier. You can see then and there. And there is an option of save also. So you can save the earlier analysis also. So you don't need to run the whole analysis. And it saves time in the table formatting, because all the interface, the result which you see, that is in the form of a Microsoft Word, the table easily gets pasted in the MS Word document. You can write the interpretation then and there. So all the analysis in JAMOVI, like I said, it is written in R language. So if those of you who are very much interested in knowing the language or what is written in the background, there's a syntax mode in the JAMOVI. You can switch that mode on. We'll see this. And then you can see what are the codes which has been written. And again, we can say that it is a point and click interface of the R. Because R, all of us wants to learn. But, once you learn this, but again, I have also learned R at one point of time. But with time, you don't remember all those commands and you generally forget, because we all are medicos, not very good in maths and, writing commands. So that's why for us, it is generally the point and click interface, which is comfortable for all of us. And that's why we find this JAMOVI very useful. So for whom JAMOVI is recommended? So it is recommended for all the researcher, and you can cite this. There's no problem. Like many PGs, they ask like, can we use JAMOVI? Can we write that we have done the analysis in JAMOVI? Because generally you will see the manuscript, they write SPSS or Stata or SAS or any other software. So can we write that? So yes, definitely you can write JAMOVI because it is open source. Again, in SPSS, you need to pay for it, even one subscription, one for 1 year, it approximate cost is 7 to 8,000 rupees. And there are limited modules. So it's better that we use JAMOVI. Those of you who can use SPSS also, then you can use both these, software for analysis. So I have told you how to download this. And you can see this slides was these slides we made earlier. So that time it was 2.2.5. Now you can see it is 2.8. So how the version it gets on, increasing. Currently, I have shown you it was the 2.8 version. So now we'll go after this to the next, after learning this, we'll go to the next session that is on the concept of variable. Or before that, I think, yes, I'll tell you about something about the data entry, how to enter the data. So in this, before we go for the concept of variables, we'll see the data management. So data management, again, of late, we always receive many data sheets, either from faculties or from department or related to project, or you do projects, you do your PG thesis, you do a lot of other activities related to research. You will see that many times you will receive an Excel sheet where you cannot do any analysis. Why? Because you will see that the data is not in the form where you can start analyzing. Because analyzing the data will not take much of the time. It is the most important time or the large part of the time we spend or in getting that clean sheet. And that's why I always emphasize that all the researcher, you should always consult a person, or you should learn before you start collecting the data, how you are going to collect the data. That means how your Excel sheet will look like, how to create variable. Once you do that, then half job is done. So that's why we always like in here in the to the clinicians also, we always emphasize that it is very much similar to the operation theater management or any procedure management. So this operative management versus data management, just an analogy between these two, although we know that here most of us are from the community medicine background, but even if you are not from a community medicine background, you are a clinician, hardcore practicing clinician, or working in the field. In the field also, you will see that you need a lot of preparation for any activity to be executed. And here what in research, what we do, we just go with the proposal, start collecting the data. Once we are done with the data collection, then we go to the research, the biostatistician or the people who analyze the data, asking them to yield some fruitful result or to yield something statistically significant. That's how the version of all the students are. That, ma'am, please, isse kuch nikal dijiye. You take out something good from this data. But ultimately, you will understand that if you have not put a lot of brain into collecting those data, and if the quality of data is not good, then no way any statistical method cannot yield a good result. Good means whatever you consider it as a good, because the negative result, generally people think that no, we don't accept negative result, but we always encourage, no, negative is also a result. So you should always accept whatever has come in your data, but that authenticity will only come if you have put a lot of energy in the true collection of data. So before we go into the analysis of any data, Mind it, if you have not put a lot of effort in data collection process, in training the people how to collect the data, then definitely I'll say that whatever hypothesis you make or whatever research question you start, I don't think that you will get an authentic result. So that's why like we say that pre-anesthetic checkup is required before data collection, similar this operation. Similarly, the cleaning of data requires a lot of time. So approval may take hours or few days to get fitness for the analysis. So in operation room, if you see that operation theater time, it may run from 1 hour to 10 hours depending on the complexity of the issue. Similarly, analysis also may take 20 minutes to few hours depending on the complexity of the analysis and the type of result which you expect. And similarly, in the post-operative period, you may continue for a few months to years till the patient gets complete cure. Here in the post-analysis period, again, till the manuscript is published, you keep on analyzing the data because you have sent it for the peer review and the person has asked for some other type of analysis, and then again you redo the analysis. So you keep on doing that analytical process till your manuscript is accepted for the publication. Both skills are highly focused and it needs a lot of engagement from the researcher and from the surgeon point of view. The only difference which we say that there is no undo function and redo function in case of operative management, which is doable in case of a data management. But that is only doable in case of a data management. If there is a problem in the data collection, you cannot go back and take the data again because it is very difficult to go again back. Then generally such outliers you tend to remove from your analysis. So there are three processes of data management. First is the data collection plan, and data collection plans should be thoroughly discussed, and the data collector team, and whatever is the data collection team, if you are doing a project, like if you are at a professor level or additional professor or maybe assistant professor or maybe a senior resident, anything, even if you are a junior resident and you are doing your own project, your own thesis, then also the genuinity or the with honesty, the with which you collect the data, that is the heart of the analysis. So that should be there whenever you do the data collection. And you should always consult a person who is well versed in those techniques, how to collect, which variable, how to enter those data. And then there is a second step is the data entry, cleaning and coding. So these days, generally, there is a digital data collection. So the problem of data entry that from hard copy to soft copy is not there. But again, in the digital data collection also, you should have some checks so that you don't enter, or the investigator who is like data collection team, which is entering the data, they should not enter some wrong data. And then it is next is the cleaning and coding. And third is the data analysis plan. So all this data management that involves these three processes. First is the data collection plan, which is the most important because you cannot go back to the field or to the patients to change this. Yes, the other two like the data entry, cleaning, coding can be done. And analysis, definitely it is in your hand. If you have data, you can play with that data and you can try yielding different concepts and different hypotheses. So if you want to enjoy your data analysis, please ensure a cleanest possible data entry and keep on checking the data. So some random checks also you should be doing. If you are doing a project and if some other person is doing the data collection, you should do some random checks just to ensure whether that entry is correct or not, or whether that value is correct or not. So there are some basic rules of this data entry. So there are two ways. In any of the software, generally there is a provision that you can directly enter the data also. Like in SPSS and JAMOVI also you can enter the data. But if you are using a Google, this thing for the data collection, Google form, then it gives you a Google sheet in the form of a like variables, which you can import it as an Excel. So direct approach can be there when you can enter the data directly into the software like JAMOVI, SPSS or Stata, or indirect approach where generally you enter the data in Microsoft Excel or Google Sheet and then import it to the respective softwares for analysis. So we always encourage the participants or all the researchers, students to enter the data in the Excel sheet, because Microsoft Excel or Google Sheet, you can import it in any other software and things are easy. So, and it is easily doable. So first, please note this, that you do the data entry into the Excel or the Google Sheet if you are using a G form for the data collection. Then there is a second thing, which is the sample data set for, this is just, we have shown you, there are 5 individual you can see. So in any Excel, what do you see? There are rows and there are column. What is a column? So if you see, this is basically a column. Like there's a column for gender. There's a column. So you can see this is a column for age. This is a column for weight. And then this is a column for height. So these are various columns. So in each column, what do we enter? We enter variables in each column. So each column is for one variable, remember. In Excel also, because of late we have received an Excel sheet where all the variables were in the rows and all the individuals were in the column. So it was very hodgepodge. And even if you like, obviously you can transpose, there is an option of transpose in the Excel sheet, you can do that. But still, if you are starting afresh, all the variables should be there in the column. Now then, what is this row for? So this row is for one individual. Like this is the serial number 1. And this one individual should be, it is the gender, age, weight. So how can I say that this ID number 1 is a male patient of 22 years age, of a 67 kg weight, of a 160 centimeter height, giving a pain score of 4, status of pain is severe, and is a smoker. So each row is for one person and each column is for one variable. Did you get it? All of you. This should be noted, because then otherwise, even for people who are senior, you will see that once you get these sheets, it will be very difficult for you people to redo or get the entry done again. So each column is for one variable, like you can see here, gender, age, weight, height, pain score. Each column is for one variable, and each row, it is for one subject, study subjects, or the unit of study. Whether it can be like if you are in pathology and if you are examining slides, then this row will be for one slide. If you are doing a microbiology plate culture or agar culture or something like that, then each row will be of one culture plate. So whatever is your unit of study, whether it is a histopathological specimen or patients or blood sample if you are in biochemistry, or any genetic immunology, anything. So your unit of study, whatever is your unit of study, that will be in each row. And all the variables which you have taken, that will be on a separate column. So that is the first thing. The second thing which you can see here marked in red, it is the non-coded. So what do you mean by non-coded? Here you can see. Now can you please write in the text box which are the variables here which are non-coded? What do you mean by coding and non-coding? Yes? So Ankita is writing pain score, smoking habit. Pain status, smoking habit, all are non-coded. Gender, pain, Nitin is writing age. Suman is writing age, weight, pain. Okay. So generally a variable, we will learn this, but a continuous variable like age, weight and height, we cannot code that. Why? Because it is a continuous variable and coding is done only for those variables which are qualitative in nature. We'll see this. But just to make things simpler here, there are two sort of variables here, gender, which is male, female. So whatever you write in words like mild, moderate, severe, or yes, no, that is a non-coded. Why? Because you are writing words. Coded means you are giving a number to it. So all these like age, weight, height, since they are already number. So that's why they will always be non-coded, because they will always be in a actual number. That's why these are known as the scale variable. We'll see these concepts. Don't worry. If you are not understanding this now, don't worry. We will cover this in the session of variables, because there is a separate session on variables. But just to show you that since these are the characteristics, gender is characteristics. I can be a male or a female. Age is a absolute, it's a number, because I am 22, I cannot be anything else. If I'm not 22, but if like, just for example, the serial number 1 I'm saying. So similarly, pain status is also severe. So you can like write this severe and mild, moderate. Again, you can depict it with a number. Like you can see this. Now, what is your status? It is a coded. So you can see the code. I have given the code gender 1 as a male and 2 as a female. Similarly, I have given the pain status 1 as a mild, 2 as moderate, and 3 as severe. And smoking, if you see, 0 is for no smoker and 1 is yes, a smoker. So I have converted these characteristics, yes, no, mild, moderate, severe, male, female, as code. Code means I have given a number to it. I have given 1, 0 or 1, 2. It is not necessary. You can have your own numbers. You can give 3, 4, 5, 6, whatever you are. But since generally the software, there are many analysis which can be done only if you enter these codes. And in JAMOVI also you will see, we'll see in the correlation. If you don't have a coded data, you cannot run correlation, right? So that's why we encourage to do a coded data entry. And that code, that's why you see that, and you should have a separate code book. Generally, what we do that in Excel, if there are one Excel sheet, so the one Excel sheet we have that data entry, and in the other sheet you can write the codes like what is this 1 and 2, and what is this 1, 2, and 3. Like I have written here that gender 1 means male and 2 means female, and in JAMOVI you have to enter that. We'll see that. So we recommend coded data entry, especially if you are in anesthesia or any perception tool you are using, where you are like taking the responses as a highly disagree or agree or disagree, agree to somewhat like this. Then if you don't take this into number, you cannot calculate the mean score. So that's how we recommend that such type of data entry should not be there, where you are writing everything and there is no code to it. So there should be a code, and you then define the code, like what is 1 and what is 2. Now this is one, you can see here, this is one way of, there are two groups. So I am doing a randomized control trial and I have got two groups, group A and group B. So you can see here in the heading, this is an Excel sheet, and this is a one heading for group A. And I have entered, and these all sheets we have received from our PG students or from faculties. So now can you suggest, like, do you think that any problem in the data entry? This is for group A. So this was for the standard treatment, and this is for group B. This was for the intervention arm. And like I am having these variables like name, age, gender, symptoms, blood pressure, height, weight, and TSH. Yes. So now it's your turn to answer or write. Symptoms not proper. Dhanya is writing multiple entries. Agree? Symptoms should be in different column. Bharat is writing. Okay, good. So two mistakes you have pointed out. Anybody else who would like to add? Hilda is writing gender can be coded. Agree? Dhanya is writing BP. So what is the problem with the BP? Okay, Prashant is writing BP should be separated. Varalakshmi, BPS systolic and diastolic, agree. All of you are right. What is your comment on this group A in one Excel sheet? and group B in the second Excel sheet. If you have received a data Excel sheet, in one sheet group A and in the other sheet group B, is it possible to do the analysis? Okay, so Prashant is writing we cannot compare. Okay, should be in the same, yes. But many times you will see, especially from the clinicians, the PG students, they come with such, if there are like, we received one time in anesthesia, there were 4 arms, like one standard, and they have used 3 other interventions. So all those 4 arm were in 4 different Excel sheets, like sheet 1, sheet 2, sheet 3, and sheet 4. So no, that should not be there. Nitin is writing one Excel sheet with a column study group coded as 1 and coded as 2. Yes, Nitin, you are perfectly right. And then Bharat is writing that we can merge and have a separate column mentioning. Agree? For paired t-test, separate is better. So separate, no, for paired also, Dhanya, you need to have it in the single Excel, because if it is separate, you cannot run the analysis. Okay. So for paired t-test also, you need to have this, like Prashanta and many other people have said, that there should be a column where you can write that this participant belong to which. Remember, in the beginning, I have showed you one Excel sheet with the 5 individual, each row with the individual. And randomization also you do like that. The person comes to you and you assign him to one arm or the other arm. So that belonging to which arm is again a variable, which should be in a column. Now we asked him that please go back and merge this into one sheet. And now he has come up with this sheet, that person. This was a true episode, but just like I'm not naming anyone or any department, we are not, because we can also do the same mistake. So Bharat is writing this is not merging. So what problem it is showing, Bharat? Yes, agree. But what problem can it have? What rectification can be done in this sheet so that we can analyze it? Any other person can also write, or you can unmute and speak. So Bharat is writing that difficult to analyze. Agree. But what instructions you will give that PG? That please rectify this. What? We can keep separate column. But there are separate columns for group. Okay. So group A and group B, and then can be group. Okay, agree. So now I have returned this sheet back. Now he has done this. So now all of you please focus. He has done this. He has created one column with a group where he has written group A, and B. Okay, Dr. Perumal is writing that we can give numbers for subject. That ID, yes, we give. So Dr. Varala Lakshmi is also writing, you can add a column to the code group. But yes, he has added a column. Okay. So now, where is the mistake? So earlier mistakes, I can see you have written symptoms and BP. Those are still needs to be rectified. What about this A and B? Should you be doing the entry like this? First all A and then all B? Okay, so Dr. Pragati is writing group B entry to be continued just below the last entry of group 1. So many of you think similarly, but it is not necessary because it is not mandatory. Generally, why? Because in research also, you don't do like this. You keep on entering and the patient keeps, you don't do that first, you complete with the intervention and then you take the control. Generally, everything is going simultaneously. And yes, if somebody has done it like this, no problem. But even if it is not like that, it is random A, B, and B, it does not affect the analysis. Yes, agree? Then you see the next. So now he has entered like this. You can see, you can focus on this first column, which is the group column. This is A, and B. So you can see that here he has read, like it is random, A, B, and then something like that. And then you can see that he has entered now. you people were saying that we should have a symptoms in the separate column. So then we have returned this sheet to him, and then again he has come back separating the symptoms like this. So symptom 1, symptom 2, and symptom 3. So is it, and he has separated this blood pressure column also. BMI's column empty. The Bharat is saying that BMI column is empty and empty cells affect analysis. Okay, agree? So what do you advise him? To calculate the BMI individually and then enter? Or something else can be done? Shivam is writing group A code 1 and group B code 2. Yes, can be done. We can apply formula. Agree? So now, yes, you are right. Formula of all cells. Monica, so all of you are writing correctly. Dr. Reggie is writing BP classification and codes to be given. Yes, we will do that depending on whether we want to take blood pressure as a categorical variable or as a continuous variable. We see that. So Hajan Chakrabarti is writing that symptoms wise column. So do you think that this is okay, this symptom wise column? Or if not, how it can be, it could have been done? Yes. So Hajan is writing fever. Okay, so you want to say that categorical. So like cough, one category. It should be separated for each. Separate column for fever and symptoms. Yes and no for each symptoms. Okay, so all of you have done a wonderful job. You have pointed out the mistakes correctly. So now you can see that we have taken your advice and feedback. So all these symptoms like fever, cough, swelling, body ache, and these are like yes and no. Okay, and then we have filled this BMI column also using the formula. Shivam is writing yes, missing data can be 9999. Even if you don't do that in JAMOVI, that does not create a problem. And then symptoms coding for fever and cough like 1, 2, 3, 4. But Santosh, if you do like 1, 2, 3, 4, then again, if you want to know how many of like people they had fever, then it will be difficult for you if you like enter in the same this thing. Because there can be multiple symptoms to a patient. So that's how you can have a data entry. Now this was again a this we have received from ICTC clinic, and the person has written address like this because we wanted to make a map of the spot map of the people, all the HIV positive people, and they are like focusing on which district. So if you want to make a spot map, so this was a data of I guess 33,000 people. 33,000 people, and you can see that this was the entry. So now state, city, district can be separated. Yes, but initially, once all the data entry was done, 33,000, then you can think how much time it took to correct that. Because here you will see that somebody has written Patna, Bihar, India, Patna, Bihar. Again, the spelling is different. Jahanabad, Buxar, Bihar. Somebody has written 2, 3 places. Then there's an option in this that you can separate that comma. If there is a comma separate in the same column, again, you can separate that in Excel. But yes, Monica is writing, we can do the data validation. Correct. So that's how all these examples we have just shown, many of you already know this. But again, just we thought that all of us should be on the same page before we go for the further analysis. So data entry should be clean. And then like you people said, again, this address is again not correct. So here, what should have been done? Like state separately and district and country. Yes, Divagar Nagar is writing correctly. Dhanya is writing what is the data validation. Basically, data validation is like you put some checks in the data entry. And like age, if your range is like 18 to 40 years, then you disable entry which is less than 18 years. Or you disable entry, you give a command to the Excel that it should not take any data which is less than 18. So that's how wrong entry, it will not take, Dhanya. That's the data validation. So this was again one sheet. You can see this sheet we received during the COVID time, and they wanted to do the analysis and see the prognostic factor. And that person has entered the data like this. Sorry. Entered the data like this of 440 patients. And this was from, I think, one ICU or one medicine ICU or some ICU. And then you can see like even like no amount of time can correct this data on the Excel. Then again, that person re-entered the data, and I think it took approximately 8 to 10 hours again in doing that exercise. So you can see like how he has entered. He has like one column he has taken, but like ferritin, dimer, and all these are also not in sequence. Sometimes he has entered WBC, D dimer, later on, sometimes initially, something like that. Okay. So this, so you will receive, if you work, you will see that you will receive many types of Excel sheet, and it takes like 2 to 3 days to get those Excel sheet corrected. And then only you can analyze. So through all these examples, and these all are real example. We are not like exaggerating any example. This all we have faced while we did the analysis of many of the residents and faculties. Even our residents have maybe they must be receiving many Excel sheets which are not in the correct format. So Bharat is writing uniformity is missing. So with all this, this was just to sensitize you regarding the importance of data. And with this, the two take-home message which we want to convey. The first is, remember, each column is for one variable, each row is for one individual. If you remember this, you will not make mistakes. The second is, whenever you plan to collect any, like if you are at a senior level probably, and if you are leading a project, always check, like one is the data validation, but again, think thoroughly in what field and how the data entry will be there. Just to, in many big projects, you will have a separate person for all these data advices, but still you should be knowing, because if you don't know, you cannot lead them. So that is needed if you are a PG residence or if you are a senior resident level, then always plan your data, how you are going to collect it, and recheck in between. Do some verification checks so that the data which you have, that should be good, a really good and honest data. And you will hear many people saying that garbage in and garbage out. That is again said with this data, that if you are putting garbage in and whatever you try to take out, that will not give you gold. That will always give you garbage. So that's why there's an importance of this data. Now coming to the another session, that is on the variables, because many people, while I was telling you, people said that age and blood pressure and BMI probably, that is the where the coding is not there. So we need to understand in what type of variable we need to put the coding and what is the concept of variable, because in JAMOVI also you need to specify which type of variable it is. We'll show that. So this is the concept of variable. So what is a variable? How do you define variable? Variable, as the name suggests, which varies, which is not dynamic. Whatever we collect from a person, age, or any biological parameter, that is different from one person to another. So whatever we measure, that is variable, and variable which is likely to vary, which is likely to change from one person to another person. And then it is a characteristics which we measure from a person. So in any person, like if you ask about me or anybody else, we have got a lot of variables. It depends on the researcher in which variable he or she is interested. And he or she collects only those variables which are needed for the research. That's why you see that in a protocol submission, there is a separate column for variables, which variable you would like to collect, or which variables are you collecting from that person. Like you can see this, let's say I'm interested in the myocardial infarction cases. So this is a whole population of myocardial infarction cases, and I took few sample, and that's why those concepts of like sampling and sample size and how you are going to collect those samples from the population. So these are the sample, and then you collect a single patient. So that single patient, and then you see the variables like age, gender, what is the race, what is the status of cardiovascular disease, what is the state of serum cholesterol. And we can say that this person is 45-year-old male, white, with a history of cardiovascular disease and serum cholesterol of 230. So here I am talking about one patient means one row. One patient means one row in the Excel sheet. And all these variables like age, gender, race, this will be in the separate column. Similarly, if you are measuring variables from many people from this population, like let's say 10 people. So this accumulation of 10 people or each unit is called datum. And then this 10 collection of this 10 people will be known as the data. So data is just the plural of the datum. And that final value which we will receive or which we will calculate, like there will be 10 ages, 10 gender or the 10 blood pressure. So all these will be known as the sample statistics. So there is something known as the sample statistics. Because we have collected this sample from a population and we are calculating the mean or median or whatever descriptive or any other statistics, this will be known as the sample statistics. And if you are measuring variables for everyone in the population, which is not possible, but theoretically, if you measure everyone in the population, then it is known as the parameter and it is known as the whole population. So for population, we use the term parameter. For sample, we use the term statistics. So that's why generally we write biostatistics. Why? Because we cannot measure everyone in the population. And that's why we are doing the research, because why we want to project or we want to tell about the population parameter, because that is not known, that is unknown. So through that sample, we want to extrapolate or we want to convey that population parameter. So there will be population parameter for age, gender, race, serum cholesterol, etc. So for any given variable like age, gender, there will be sample statistics, which generally it should be nearly equal to that population parameter, but that is not always so. So there is a discrepancy between the two value, and that discrepancy is known as the sampling error. And that's how we want that if the sample size is accurate, if our sampling strategy, how we are taking that individual from the population is correct, then this discrepancy is less. And then your sample statistics will be very near to your population parameter. Bigger the sample, lower the discrepancy. That's why you will say that we always emphasize on a adequate sample size. It should not be too big also. That doability thing should be there. But bigger the sample, lower the sampling discrepancy. So let's revise. A variable is a characteristics that change or has got different values. Data is a measurement or observation, and data set is the collection of those measurement and observation. So this is just the repetition. So I'm not going to tell you what statistics is. This is again observation leads to measurement. You can see this picture. What is this for? This is some personality trait. You can measure this through questionnaire. This is a blood pressure. Sorry. We are measuring the blood pressure. This is the thyroid swelling. This is the blood baby weight. This is the central adiposity. So all this you can do the observation and you can measure. So measurement is what? You give a number to the various aspects, to the objects or the event according to a rule. And we want that numbering and that measurement, it should be accurate, it should be objective, and it should be sensitive. So now there is something known as the nominal. So many of you must have heard this. For many of you, it is just a repetition. But for those of you who are new, or maybe many times we forget also. So just a refresh, quick recap. Nominal is like a gender, where the number does not matter. That means it is a characteristics. 1 is for male and 2 is for female. But if I do 2 for male and 1 for female, by giving 2 to female, I am not meaning that the female is superior to male. It is only that For convenience sake, but you can reverse the order also. So if your data has got a characteristics like color of eyes, color of hair, skin color. So if I'm giving 2 to a fair person and 1 to black, that does not mean that 2 is a lighter version of skin. It is just the characteristics. If I reverse the order, that is not going to change the meaning for a software. So I can do 1 for as a female also and 2 as a male also. So if you change the number, the meaning does not change. That we mean by a nominal measure. It's a characteristics, and any characteristics like gender, or maybe you can say the color of eyes, color of hair, color of skin, blood group. Let's say blood group. If there are 4 blood groups A, B, AB and O. So if you give 1, 2, 3, 4 to these blood groups, I don't mean that 4 is the higher and 1 is the lower. If you reverse this, that is not going to change the meaning. So nominal is this. Any characteristics where you change the number, but the meaning does not change. The next comes the ordinal. Ordinal is what? There is a order. Like pain. If I'm giving 1 to a lower pain, like less pain, definitely I'll give 3 to the higher pain, like mild, moderate, severe. So there is a order. I cannot give 3 to mild and 1 to severe. Can I reverse the order here? And will it change the meaning, or it won't change the meaning? If I give 3 to mild and 1 to severe, so is the meaning same? So Dr. Sumana is writing no. You are right. So in case of a ordinal, we cannot reverse the code. Reverse the code, or we cannot give higher value to something which is less, because it will change the intuitive meaning of the data. So this is known as the ordinal when there is a definite order. Have you understood, all of you, up till this point? Nominal and ordinal. Rank data. Dr. Anand is saying, agree? Any ranking, whether it is a tumor, like stage 1, 2, 3, 4, or first, second, third, fourth in the class, any ranking, it's the ordinal. And nominal, you are giving a number, but that number, higher number, does not convey that that is at a higher rank. That's the only difference between nominal and ordinal. Yes, you are right, Dr. Selvaraju, that SES is again a ordinal, because there's a income and low income, middle income and high income again as a ordinal scale. Now, again, there are 2 other type of scale, which is known as the interval and ratio. So interval, there's a classical example is the time. Why? Because you see that the difference between 10 to 11 a.m. and 8 p.m. to 9 p.m., which we have shown it here, that is same. So if you see this difference and this difference is same. But for a ratio, you see that there is an absolute 0. So from 0, you are measuring this 20, 21, 22, and 23. There is an absolute 0. Because if you see that in this example, can you tell that the difference between these two these are the 2 weights. This is 10 kg and this is 5 kg. So can you say that the difference between the 10 kg and 5 kg is 5? Please write yes or no. Can you say that? Okay, good. Dr. Ajay, Nirmal, Dr. Kanan, all of you are right. Now coming to this second example. Can you say that the difference between 10 a.m. and 5 a.m. is 5 hours? Okay. So all of you are right. Now, coming to the second question. Can you tell with certainty that 10 kg is twice than 5 kg? Can you say that? Yes. Agree? Can you tell that the 10 a.m. is twice that of 5 a.m.? No. Why can't you say that? Because there is no absolute zero in case of a time. So the reference point in the first case, which is the weight, that is actual. Whereas the reference point in the second case, which is the time, because for time we take 12 at midnight as a reference point, 0. But that actually it's not 0. So that's why the ratio, you cannot say that the 10 a.m. and 5 a.m. is twice. Interval, definitely difference you can say. So that's the difference between the interval and the ratio scale. But together we call them as a scale variable, because there are very few variables which are interval. Generally, most biological variables are the ratio variables, or they're on the ratio scales, measured on the ratio scales, and we call them as a scale variable. Scale means you can measure it with a scale. So that's how you will see in JAMOVI also, it is shown by a yellow, small yellow scale. We'll see that. So this is the difference. So if you see the levels of measurement and hierarchy, then the weakest is the nominal and the highest is the ratio. It is the of a producer stronger evidence. So now coming to the dependent and independent variable. So what is a dependent variable? So in this case, for many of you, it might be a repetition. But for those of you who are who have not heard this or saw this, so what do you see in this picture? Yes, all of you, please type in the chat box. Okay, so plant growth is dependent. Plant and so you have already answered that there are different amounts. So you can see there are different amount of drops. This drop is the biggest. This drop is the smallest. So the amount of drops, this one, and this one. This is different. And you can see this amount of water is falling on these three plants. So you will see that this is the plant, number of leaves in the plant and size is also different. So you can say that that amount of water, it is what? Dependent or independent? Yes. So Utkarsha is also writing the different size of drops. So drop will be your independent variable. Yes, because that is having an impact on the size of the plant. So amount of water and effect of plant. So in this case, which variable you can change? Amount of water or the effect on plant? Yes. Amount of water. Yes, because if you change the amount of water, the effect on plant will be different. So the independent variable is the variable that is changed, which is the water. And the dependent variable is the variable which gets affected by the change in the independent variable, like size of the plant, number of leaves, or whether it is living or dead. So that's the difference now in the if you see this scale variable is also known as the continuous data. And there's again one concept which is known as the discrete data. So discrete is where there is a fractional value is not possible. So like I cannot say that the number of children in a family is 3.3, 3.1. That cannot be there. So it will always be in discrete. But if I have to say hemoglobin, I can say that it is 12.1. So in case of a discrete data, gaps between the possible, there will be gaps in the possible value. Like between 3 and 4, there will be nothing. But in case of a continuous data, there won't be any gaps between the possible value. So if you see the data that characterizes but does not measure properties of a thing, that is known as the qualitative or a categorical data. And qualitative data are not numerical in nature, but we assign numbers to these data and they are only for labeling purposes. Otherwise, it does not have an intuitive meaning. So that's why when I pose that question of Excel, like age, gender, and the blood pressure, then many of you have written correctly, but there were varying sort of answers. So originally, the data which is qualitative in nature, If you collect those data, you give a number to it that is only for labeling purposes. Otherwise, it does not have a meaning. But there are many variables which are originally as a continuous or numerical. Like we see creatinine level, blood pressure, age. It will always be numerical. Originally, that variable is a numerical. So numbers are not for labeling purposes. Rather, the numbers are there. So like in this case, a gender, socioeconomic status, skin color, pain, all these are the religion. These are the data which is generally numbers are used for labeling purposes. So if I have to classify this data, so there can be two types of data: quantitative data, which is also known as the numerical data. There are two types of quantitative data, like discrete, like number of newborn in a ward. It will not be in a fraction, so that will be discrete. And then second is the continuous, where the fractional value is possible. In qualitative, we can have a ordered and unordered. And similarly, qualitative, this nominal and ordinal comes as a qualitative. Ordinal has got a middle value. It can go into the quantitative also if your level of scales are more than 5. We will discuss this later, but ordinal can come to the quantitative also and can go to the qualitative also, depending on your research objective. So why there is so much of importance of these two types of data? The qualitative and quantitative data behave differently, and therefore they are studied differently. So the level of measurement determines the type of statistics that is appropriate for the analysis. So this is, we are done with the sessions, and then there is a 5 minutes break, and then we'll again come here. Then I'll show you the JAMOVI and how to import and do the activity, and then we can there. So there's a 5 minutes break. Right now it is, if I see, it is 10:49. So we are, okay, so Nitin is previous slide before thank you slide. Okay. Okay, Nitin, I'll show you that. So those of you who want to be here, like you can still ask questions. But those of you who want to go for a break, like just have water, something, and then you want to come back. So this was the slide, Nitin. Just as an example, we have shown you this. I wanted to emphasize. So this is a break, but those of you who want to stay here. Okay, Bharat is writing again. Can you emphasize on qualitative and quantitative data? Yes, Bharat, definitely I can emphasize. So qualitative data, again, like, okay, audio is low. Okay, let me check again. Audio setting, it is maximum. Mic check, mic check. Yeah, I'm doing it. So, is it okay now?
Yes, ma'am. It's okay.
So, was it low since the beginning?
No, ma'am. Last 30 seconds.
Last 35 minutes?
No, 30 seconds only.
That's okay. Otherwise, Naveen or any participant, please, okay. Dr. Bharat, it is okay. You can always interrupt in between, because if there is an issue with the audio, the whole purpose will be defied. Okay. So yes, this you can see that coping and so Bharat wanted to have a discussion, or rather a quick recap on the qualitative and quantitative. So yes, I'll again explain that. So qualitative is basically when you measure the characteristics. I'll go again. So qualitative is also known as the categorical data because you have a category. As for example, okay, Pratap is writing, also clarify a bit more on the interval and ratio scale. Okay, Pratap, I'll tell again, once again, all these 4 variables. So qualitative, remember that NOIR, N-O-I-R, NOIR, in the short form, you will see that we call it as a NOIR, nominal, ordinal, interval, and ratio. So the first 2 generally we classify as qualitative data. Now there's again one qualitative data, which is the qualitative analysis. That research technique is different. Don't confuse that qualitative data with this qualitative. That qualitative is qualitative research method in health where we do the coding. There also we do the coding of those lines, but that is different. Here we are talking in the quantitative research, we are talking about the 4 levels of measurement, and there is something known as the qualitative data. So the first 2 levels of scale measurement, that is the nominal and ordinal. We call it as a qualitative data or a categorical data. We will see in JAMOVI that you need to specify that your variable is a nominal or an ordinal or a scale variable. So the difference, what is a nominal variable? Nominal variable is a variable which measures the characteristics or trait, but if you change, we give a number to it. But the higher number does not mean that ranks high, like gender, like color of eyes, like religion, Hindu, Muslim, Christian. You give 1, 2, and 3. But by giving 3 to the Christian, that does not mean that they rank high than the Hindus or Hindus rank high than the Christians. So if you are giving a number to these traits or characteristics, that does not mean, the higher number does not mean that ranks high. That is what? Nominal. Have you understood this nominal? All of those of you who are here in the breakout, in the room, you can write yes and no. Nominal, is it okay? Okay. So now nominal is okay, coming to ordinal. So ordinal is what? When you give number to the data, the higher value, you give numbers as such that the higher should say the higher in rank. Like pain. There's a pain score, VAS score, 1 to 10. So if I say that I have got an 8 rank in pain, that means I have got a severe pain. And if I say I have got 2, then I have got a less pain. If I have say that my pain is severe or I have got moderate pain, so I'll give severe as 3, moderate as 2, and mild as 1. That means 3 is definitely, it is ranking high than 1. I cannot change the order. I cannot give 3 to mild and 1 to high. Why? Because if I have to calculate, why do we do like this? Because there is a definite order in those variables. There is a definite perception, because pain is again what? It is a perception. So my perception is that I am having a more pain. Similarly, if you are collecting any information on Likert scale, I hope all of you know what is a Likert scale. Like you take attitude questions or perception questions on this Likert scale. Like quality of life. My quality of life is not good. How much I agree to this statement? So I will say highly disagree, or I will say no, somewhat agree, or somewhat disagree. So, but again, I will give a number 5 to that person who say that no, I highly agree. That means my quality of life is not good at all. So that is, if I am giving 5 score to my quality of life is not good and I highly disagree or highly agree, then it shows a rank. So all those perception things shows the rank, and I cannot reverse the coding. Agree? Yeah, cancer tumor staging. Stage 1, 2, 3, 4. I cannot write stage 4 as stage 1. Why? Because that ranking is done based on the dissemination to the various organs. That's how it has been defined. Or socio-demographic characteristics, like you people have just said. If someone is having a higher per capita income, I cannot give 1 to that person, and I cannot give 3 to a person who is having earning less. Okay. So there is a definite rank. Somebody is there at a lesser rank. Somebody is like topper, first topper, second topper, third topper. Yes, any categories like depression, any score, ultimately you convert it to the categories, right? Like blood pressure, you convert all those continuous into categorical. You write stage 1 hypertension, stage 2 hypertension, stage 3 and stage 4. There is a definite order. You cannot write a person who is having more than 180 as stage 1. Will you write that? because then what it will do? It will change the meaning. It will change the meaning. But if you give 1 to a blood group A and 4 to blood group O, and if you reverse the coding, it does not change the meaning, because ultimately it's the trait. So that's the difference between the nominal and ordinal. And both these nominal and ordinal together are known as the categorical data, right? Because this mild, moderate, severe, you are not measuring with some instruments. Ultimately, through questionnaire or through scores, you are assigning one thing. So you can say that that is higher, but there is no way that you can measure the hormone level of the brain of depression, and you can say this is again subjective. It is not very much objective. So that's why these are categorical or a qualitative data. Again, I said that ordinal can go to the continuous data or the quantitative data also. And many times you will say that in scale analysis, you treat them as a continuous. Any Likert scale item which are more than 5, or you can say like 7 or more than 7, if it has got a 7 or more than 7 categories, you can treat that as a continuous data also. Is it clear up till this level to all of you? The qualitative data? Can you show me who has asked this question? Bharat, I think, has asked this. Bharat, have you understood this qualitative thing? Okay. Then we'll go to the quantitative, and then I'll again explain the independent and dependent variable. So then we'll go to the quantitative variable. So now what is this quantitative or data? So quantitative, whenever you collect the data, it is inherently in number. Like you measure the hemoglobin of a person, it will be in number. It will not be like A, B, C, D. If you are measuring the distance traveled in kilometer, it will always be in number, because it has been defined like that. If you are measuring my weight, it will be in number, right? You can definitely convert the continuous variable into the categorical variable, like you do in the BMI. You say that person who is like more than 30 or less than 30, having a morbid obesity or not morbid obesity, but originally your data has been collected as a continuous data. So that is the quantitative data. So again, quantitative can be of two types. It can be a discrete, like number of children in a family, number of days, hospital admission, 7 days, or again you can define that, but like number of children born in a family, number of newborn in a ward, number of patients admitted in a day. That cannot be in fraction. That will always be discrete, means whole number. Okay. And then second is the like continuous, where there is a in between value, it is possible, like all other parameter, like you say the creatinine, blood pressure, hemoglobin, say any variable which you measure on a person, the blood parameters or the any biological variable you measure in clinical. Generally, I'm talking about the medical science. So that is a continuous data. So Dr. Anvesha is writing, ma'am, ordinal data when gets converted to quantitative data, does the code have any higher, lower hierarchical value? Yes, that's why I say that if the means, let's say you have coded pain as on 5 Likert scale, and in all your subjects, the mean value of that code is, or that variable is 4. Then you will conclude that all the people in your study subjects were having pain towards the higher side. That's why they have got a higher value or a lower hierarchical value. That's why we say that you have to give high value to a pain which is of high nature, and less the meaning of that mean comes through these hierarchical value, because you calculate and then you do, those of you who have attended our scale development workshop, where we see do the factor analysis, the exploratory factor analysis, we develop a scale, we give a value to the weightage to the various responses, then it is always done depending on the hierarchy. So like, let's say you can say here, socioeconomic status, skin, pain, religion, these all are the continuous categorical, and then the continuous. Now coming to the independent and dependent variable, and I think you want to understand it with one example. Yes, okay. So let's say like if my response, you want to see the response of a therapy. So whether if you are giving me any drug, or if you are doing a randomized control trial, so you have taken many responses like the obesity of the person, some other risk factor like family history, and then you are giving me a drug and you want to see whether I have achieved control status or not control status. Then my BP status is my dependent variable, and the independent variable will be drug, or my family history, or my physical activity level. Those will be independent variable because they are having an impact on my blood pressure. So that's the difference between the dependent and independent variable. And any variable can be dependent and independent depending on the nature and depending on the research question. Okay, it is up to you which variable. So if you want to see the impact of any variable on the other variable, that is where you want to see that impact will be the dependent, and the variables which are your predictor variable. So you will learn more on this, the modeling, where you have termed something known as the predictor variable and the target variable or the explanatory variable, because there are various names of these dependent and independent variable. But like generally in basic analysis, the socio-demographic characteristics is the independent. They are the independent variable. Why? Because you cannot change the gender, you cannot change the social, like religion, you cannot change the income status. So generally it is situation based, and it depends, like any variable can be dependent or independent depending on the need or situation. So are we all back after that 5 minutes break? Yeah, I'm sorry. So then I'll show you the JAMOVI. First, I'll have to show you the interface that JAMOVI. So this is the JAMOVI. So let me open import. Let me first show you the. So we'll go to the breakout room, but before that, let's see one exercise. So this is the JAMOVI interface. So how this will look like? If you see this, when you open this, you have to, like, this is the window icon. On your desktop, this is the window icon. So if you click this, or you can make a shortcut key on your desktop, and then you write here JAMOVI. Those of you who have installed, so 2.3.28, this is there. If you click this, there is an option of open. Then this will be open. So first you open, whenever you do the activity, you open your JAMOVI first and then import the Excel sheet. Now, if I have to import the Excel sheet, how will I do that? So I'll show you for a separate one, since this is already there. So just a sec. I'll close this. So how will I do this? I will click this. I will write here JAMOVI. And I will click on this open. So it will buffer like this, starting JAMOVI. So this is a simple sheet you can see. Here all these, there are two sides of this interface. This is the left side, this one, and this is the right side. So your data will appear here in the left side and your output will be here in the right side. And then you can see here that there are many options. Like this is the variable, this is the data, this is the option of analysis. In analysis, you can see there are many options here, but don't worry, I have got all those installed. That's why these are appearing in my interface. For you people, it may not have so many, so you can install those modules. So now can you see here, there are 4 horizontal lines here. This one. Can you see this? This red, this corner. Can all of you see this? So here you have to click, and then you can see there is something known as the open. So if you click here, you will see there are options like new, open, special import, save, save as, and export. So all these options are not needed now. Now currently only click on this open. And once you click on this open, you can see that there is a option of browse. Can you see this option of browse? So click on this option of browse. And then I will go to that respective folder. So this is my Excel sheet, which I have to import. So I'll click this import, and you can see this here, the data file. So it can import all sort of data like JAMOVI, CSV, Excel. It can import even the SPSS data file, the Stata, the JAS file, the R data file. So it can import all sort of data files. So that's why there is no need to select any data files from this. So browse. Again, I'll show browse, and then you have to show the path. So I'll go for this. For this thing, it is my Excel sheet is situated here in day 1 demo. So I will open this. So once you click this, then you can see that these it has now this has been populated, and you can see that the variables like name, gender, age, socioeconomic status, it has now appeared here in the data. But since if you see my Excel sheet, I'll show you the Excel sheet, and the Excel sheet I have entered as a coded one. So this was my Excel sheet. So like this was the gender, age, SES, diabetes, hypertension, CVD, stroke, and whether the patient was admitted or a non-admitted patient. Discharge. So here you can see this is the variable. Now, since in Excel you have done the coded data entry, now you need to mention those codes here in the JAMOVI. So if I come here, I don't know now what is this 0 and 1. So how will I do that? Name, you can leave this. Now coming to gender. So if you double click this, you can go from the variable. If you click variable, you can see all the variables here, like name, gender, age, SES, diabetes, hypertension, CVD, etc. You can go like this, or you can go to this data also and double click on this. If you double click on this, this window will appear. So can you see this? There are many windows here. So this is gender. This is your nominal type of data. If you can write here the description also. So you can write here the gender of the study subjects. This is important when you are sending your file to someone else. Then if you describe that variable, that person will understand. Otherwise, if you have got some short form of those variables, and if you have not defined this variable, that person will not understand. So if you are the one who is going to do the analysis, you may skip this definition of variable. Then can you see a measure type? If you click this, This nominal is represented by these three: yellow, green, light blue, and dark blue. Three petal flower, you can say. And then comes the ordinal. If you see the icon of ordinal, how it is? Like small, it is like a bar, but from a smaller to a larger one. This is a ordinal. And this is a continuous. Continuous, I said that it interval and ratio, both these two, we take it as a continuous data. And this is represented as a scale. Can you see a small icon here as a scale? Small scale with the marking on it. So these three measure you have to select. So gender is a which type of data? This is a nominal data. Now coming to the data type, whether it is integer or fraction, that is there. Decimal means fraction or text. Many times, if you have some coded like qualitative statement, you can enter that also. But here, for most of our purposes, it will be integer and decimal. So gender will always be integer. So I'll select integer. This missing value, this is there. If there are some missing value, you can use that. You can write if that missing values, if you want to give, like one person was saying 999. So if you want to give some code 999, you can write that here. Even if you don't write that, it will show that number of missing value in the analysis. So this is the one and two. So now for one, I need to write, because I have not written. So one is like right male. So I'll write male to one and this to female, because I need to put the code. So you will see that I have given, because in the background, then that table you can use if you write, if you describe these levels. So that's how I have written this. Now you click this. If you click this next, it will go to the next variable, which is the age. So it is already it has taken it as a continuous, an integer. So I will skip this. I'll go to the next. So SES. Which type of measure I should select in SES? Yes, all of you, please guide me. So I will select ordinal. Yes. Integer. So 1, I have to write like maybe low, 2 as middle, and 3 as high socioeconomic status. If you write that, you will see that here also in SES, it got changed. Now coming to diabetes mellitus, hypertension, CVD. So for all these, you will see that 0 is the absent and 1 is the present. That means, yes, they are nominal. So if you can do it one by one, like I can go next. So diabetes is nominal. So 0 will be absent and 1 will be your present. But I need to do so many times. So what I can do, you can go to the variable and you can select variables from. So all these like hypertension, I can select diabetes, hypertension, CVD, stroke, COPD, and CKD. And for all, I can write 0 as absent and 1 as present. And then you uncheck this after writing. So if you go to your data, then you will see that all these hypertension, CVD, COPD, which was like 1 and 0 initially, that gets coded. Now coming to admitted, so maybe it is again 1 is the death and 2 is discharge. If this thing is like that. So it will be again coded, death and discharge. So that is how you can code the data. So just to, even if you double click it, this variable view will appear, or you can go to this variable and you can see the variable from this list. Okay. So Dr. Suman is writing, repeat this part. Dr. Bharat, if the values are given, then it becomes. I did not understand, Dr. Bharat. Values are given like, can you unmute and say? Probably your text I'm not able to understand. What do you want to ask? If the value of BP. No, so that will be a continuous variable. So they're like blood pressure, I will not change. Yes, that is again like if you want to convert it to categorical, right? That's what you want to ask. Value of BP, so I want it as a, okay. So that we'll do. How to transform the category. So that is another option. We'll see that there are two options here. This is the data. This option is of setup. Setup means variable. This is of compute and this is of transform. There are other variables like add and delete. This is an option of filter. We'll use these options appropriately. This is the option of add and delete row. So if you click, if you want to have another row like here, if you click this add column, then you can have like add insert or append. Insert means that variable will insert in between. Can you see the picture? This green one, this is in between. And then it can be append. Append means towards the last. So add, you can have computed variable also, or you can have transformed variable also. Even if you click on this option of compute and transform, it will appear. Similarly, this is the row. So if you want to add a row in between, you can write insert or append at the last, and this is delete in between. So these are the options. This filter, we will see this use of this filter also. But first, let's learn very basic things. So yes, one person has said, so how to code for all comorbidity as present or absent in one go? Okay, so that's I have like double click this. And you can select, can you see these check boxes here? Can all of you see? Once you do this now on your system, it will be more clear. So in the breakout room, you are going to do this. Can you see all these check boxes? Yes. So select all these together. I am unselecting this for now. Select this, this. So I've selected all this. And now you go and open this setup or edit. So can you see this? Can you see this upper band where it is writing selected, DM, HTN, CVD, stroke, COPD, CKD. Can you see this? So I've selected in SPSS, you have to do everything one by one. And then you can write, already I have written it, and then you can give a label to it here, like absent and present. So select all, and then like in case of a Likert scale, if all your like 20 questions, PHQ 9 or PHQ 15, if like 1, 2, 3, all the questions will be in separate column. Remember, I said that all questions are like variable. So each questions will be in separate column. And if your measurement scales have got responses, same responses. So no need to type 15 times. You can select all and then write like 1 is highly disagree, 2 is somewhat disagree, 3 is neutral, 4 is somewhat agree, and 5th is highly agree. Okay. So then, okay, Dr. Srikanth is writing, he has already done it. So good. This is how we label the variable. So if you have understood this, we'll go to the next option, which is the computation and transformation. I have shown you the imputation and the levels, how to give the names of the levels. Now, third is to compute, like you people were saying in BMI, you can compute it. So you can do that in Excel also. And you can, but don't forget to deselect this because otherwise your all analysis will be restricted to this. So I have just deselected these variables. This is not, this is just in the data it will show. Like here you are right now currently here at COPD. So this is there. Now coming to the computation, I'll give you the question. Yes, that will help me and you both. So this was the first question. Open the given data file in JAMOVI. I have shown you that. Now level the describe the following variables: gender, SES, smoker, diabetes, and all. Admitted is patient admitted at admission, ICU and ward. Okay, it was was for ICU and two for ward. So I'll change that here in the admission status. So if I only need to change double click this, one was for admitted in ward and two was for admitted in ICU. I have changed that. So ICU and ward admission status. So this was there. Now I have to compute the total number of comorbidity. If I want to know the total number a person is having a comorbidity, and I am taking like diabetes, hypertension, this presence of cardiovascular diseases, all these as comorbidity, how much comorbidity a person has. So how will I do that? I will use the option of computation. You can use the computation for calculation of BMI also, but here I am giving you for this exercise, telling you. So what will you do? You can see there is an option of compute. So click on this compute. But remember, whenever you will click this, it will appear just before that. So right now my cursor is in admitted. So if I click this, it will appear after admitted. Okay. So if you don't want that, if you want that computed variable to be near to your original variable, you can click over that. Like I want near to that because if I have to check, so it will be there at the in the here towards the last. So I will write here total number of, I have to define this, total number of comorbidity. Now can you see this? There is a black dot which appears here. Any computed or transformed variable, there will be appearance of this black dot. Black and pink, you will see that there is appearance of a dot. Dot means that this variable you have either computed or you have transformed. So, and if you keep your cursor here, it will also show this. This is the computed variable. See, it's writing computed variable. So now, can you see here, there is a small fx here, small fx. This is the function. If you click this, you can see that there are various functions which appears here. Like you can see there is an absolute value. This exp is the exponent, ln is the log, then log 10, and then keep on scrolling. This is square root. These were the mathematical functions. We will see we don't use all functions, but sometimes we use many functions. Then comes your statistical. Statistical, these are the various like interquartile range, box cox, max, and there are many options. So no need to see all these options. You can see mean, rank, round, these options. So I'll use, because I have to compute the total number, I'll use the sum. So there is an option of sum also. So can you see here sum? So I'll double click this. If you double click this, this will appear here as a sum. And then I'll select the variable from this box. So I'll select which variable I'll select, diabetes mellitus, and then I'll give comma. You have to separate all these variables by comma. Then I'll take hypertension, then again comma, then CVD, then stroke, COPD, and then CKD. So you will see that here you can see the total number of comorbidities like 0, 2, 3, 4, depending on the situation that person is having, total number of comorbidity. Okay. So this is the computation. So exercise, this is the computation. Now coming to the other option, which is the transformation. So unlike SPSS, we can use space. Yes.
Space in what?
Space, Ankita, space like in what context?
In the sense space bar, ma'am. Like in SPSS, we used to put underscore because it was not taking.
Okay,
that.
okay. Okay.
So we
Agreed.
can put like the variable also as with space, no ma'am, no problem.
Yeah. Let's do it. Yes, we can do that also. I used to do it with this thing, but yes, definitely. If you click that.
Total space number, space.
Okay, here you want to say this variable name you can say. Are you saying?
Yes.
Ankita?
Yes, ma'am. Yes, ma'am. Yes,
okay,
ma'am.
yes. I got your point. Like you want to say that when we give the name to a variable,
Yes,
then
ma'am.
it does not take. Yes, here it takes. Whatever you want to write, it takes the whole sentence.
Okay, ma'am.
Okay. Then comes yes, the next exercise is I have to use yes, transformation. Like in SPSS, also we use the transformation. Here, the first exercise is I have to make a group of like 3 age category. So from continuous, now I am making it as a categorical. And many times we do that for our analysis. So first I'll show with this less than 30, 30 to 60 and more than 60. So these are the 3 categories. So how I will do that? So I will put now my cursor near age. Why? Because otherwise I cannot check. So I'll put my cursor near age. Let me go back there. Age, and then I will click here the transform. So it will appear near to this age. So I can write here as age category. And then I can write here as source since I have selected this age and then clicked it. Otherwise, you can select variable, source variable. Source variable means which variable you want to transform. So I want to transform age. So I have selected age and then using transform. So this is a very beautiful option in JAMOVI. Once you have given any rule here in JAMOVI, you can use the same rule somewhere else also. You don't need to redo the transformation. Whereas in SPSS, you need to again redo it. But it saves this. Like I can use, right now there is no other transformation rule I have given. So maybe I can click this option of create new transform. So now here you have to write, like I can write here, this is the transformation. Transform means, or I can give this, that this is age transformation. Right. And I have to give this recode condition. So if you click this recode condition, and here you will see that this is the function, means if what you are using this. So you have to focus on this. There is a very small blue color arrow here, very small. Because for this, I need to wear specs. So this small, I click this, and then there are the operators. Can you see that there are operators? So in JAMOVI, this equal to is represented by double equal to. So this is double equal to, and in the bottom, you can see that it writes also what it means by. So this sign means equal to. That's why I say that even if you forget, like you have done JAMOVI 3 months back, and after 3 months, you feel like, no, again, I need to sit down with the JAMOVI, you will remember everything. Even if you don't remember, it will show everything. So click on this, and then this is the operator. This means not equal to. This exclamation mark and equal to. This means not equal to. This is greater than. This is less than. This is more than equal to. And this is less than equal to. So these are the operators. So how I need to use? So less than 30. So what I'll use? This operator, and I will write here 30 because age I have selected as a resource, as a source variable. So I will write here 30. And then I will write here as less than 30. But whenever you write in text, then you need to put it in the single inverted. This one and this one, single inverted. If you are giving a code to it, like 1, 2, 3, then there's no need. But since if you give a code, you cannot name that code. That's why better to use this like less than 30. Then again, I will add recode condition. Next category is 30 to 60. So I will not write here 30 to 60. In SPSS, you have to specify that. But here I only have to write like less than 60. So I will use this function. If you want to write like more than or equal to 60. Sorry. So this less than 30, and I will use less than 30. Then I will add recode. I will here use equal to. Let's say it is equal to 60. Means 30 to 60. And then I write here 30 to 60. Else use more than 60. More than 60. Okay, now there is some problem. Let me check. This is okay. The formula is misspecified. So if something happens, you need, please do it again. Let me check. So if source is again, age is there. Okay, let me check. What is our source? So source is the age transformation because I'm using this. And source is less than 30. So I am using, and you can see here it is writing male and single bracket, single tick. You can see that. So less than 30. Single this here and single this here. And then second, add recode condition. And maybe if I use like less than 60, less than 60. So it will take like 30 to 60. 30 to 60. Okay, yes. That's why it was not taking. I am not, this was like less than, and you have to type here, no, this tab, with the tab it will come to this window. And then here you can use 30 to 60. And then here you can write like more than 60. And then again single. So now it will take. So what mistake I did? By mistake, I typed here in this both less than and 60 here in this function, this operator window. That's why it was writing that your formula was misspecified. So if something happens with you also while you are performing any functions, don't get this thing again, redo. Just cut all this and redo it again. So now you can see that this age category, if I close this, you can see this, close this also. You can see, and you can check also that this is 61. So this is more than 60. This is 28, this one. So this is less than 30. So you can check also whether the categories has been created. And then you can, that you can see, Anshuman, less than or equal to it, it is less than or equal to 60. That means you can do that. What values that are equal to 60. So generally we write that less than 60 means 60. You have to specify that 60 if you're writing more than equal to 60. Yes, you are right that it should be more than equal to 60. Then 60 will come in the third category. I got your point. You want to say this, you can see, you can click this edit. So if I write that else means more than 60, I am writing this more than 60, that means more than or equal to. Here you can write or equal to 60. Because here you have specified it as a less than 60. So 60 here will be included in this more than equal to 60. Okay. Otherwise, you can, if you want to include this here, then you can use this operator, because there is an operator which is less than equal to 60 also. So you can use this also, less than equal to this one. Now there are two, so I need to delete the former. You can do that also. Okay. If you want to include 60 in the second category, you can have an operator less than equal to. Okay. That is there. Don't go by that confusion in which category you will include whether 60 or not. It is up to you. If you want to include 60 in 30 to 60, you can take the operator as less than equal to 60. And then here I will change as more than 60. More than 60. Is it okay to all of you? The only thing to remember, put it in a single inverted comma and select the operator from this place. From this small, there's a small window, and select the operator from there. So Nitin, Varalakshmi, Anshuman, is it clear to all of you? Regarding that, don't go into that detail of where you will include 60 or more than 60. That is there. That concept you have. So the respective operator you can select. If you want to use 60 in the second category, you can use less than equal to. If not, you can use less than, up to you. But JAMOVI automatically takes. So there are two key messages in this activity. First thing, you don't need to give both the situation, because in SPSS, those of you who have done it, you will see that you need to, here, you need to only give the higher value, not the lower side. It takes automatically the lower one. So less than 60 will include, no. Dr. Nitin, it does not include that less than 30 also, because you have given one, this thing, just before that category, you have given this less than 30. So automatically it takes more than 30. It will not have, and that's how you can check also. I said now that you see individually also you can check these values.
Ma'am, it's like the first rule will be applied first.
Yeah, the first rule will be applied first.
Applied first.
You can see that 17 is there in less than 30. And in less than this thing, yes, in 30 to 60, it is only this thing. And in more than 60, it is 62. Right. So less than 60 will not include 28. And like Naveen said, that the first rule will be applied first. And Ankita is writing, if we would have put less than equal to 30, then it would be taking 30 also. Yes, you can do that. We'll again double click this. You can double click this. You can see age transformation. Click on this edit. If you want to select an operator here, which is less than equal to, so you can click that, but delete that previous operator. So I have deleted this, and here I can write less than or, because you need to less than or equal to. So here you can see that 30. This age this it has taken as less than or equal to, because 30 will now be in the this category. So is it clear, Ankita? Okay.
Yes,
So you
ma'am,
can
clear.
edit, just double click this and you can edit and you can check. That's why I said that you create this transformation, try to create this transformation next to the this variable, original variable. So you can cross check with the individual data point, whether the rule which you have given, it is taking that rule or not. Okay. Now, one more thing which I want to emphasize, that you can use the same rule somewhere else. Although I don't have any other, suppose if you are taking the hemoglobin at 3 different levels, or if you are taking father's age also along with the son's age, right, or mother age, and you want to use the same classification because if you want to compare it, then you can use this. Let's say, for example, any other continuous variable, it's not there. So you can select the same rule. I'll use, okay, let's say I am, this variable is father age. So this will be your continuous data, and I will put some values like father age will be definitely 40, and then 50, 45, and then 35 or 57. And if I want to use this transformation here, so I will click this, or no, what I can do, I can click this transform, and this fiber age transform, I will use this category, and then source variable is father age. Now I want to use the same formula. So what I will do, I will put this age transformation. If I click this, you will see that it automatically takes this transformed variable 30 to 60. So it is very useful if you are creating categories there in many places. If you want to have the same same transformation rule, you can select this rule from this drop down menu, or you can have your new transformation. What Santosh is writing, 153rd row age transformation. What is the problem there in 153rd row? I don't see. Let me see. You can keep on doing that. If there is any problem, you can see that 153. What is the problem, Dr. Santosh, in 153 row? I don't think any problem will be there. The only thing how you have specified is whether you are taking 60 inside or 60 outside. 60 is not transformed, no, but here it is transformed in my case. See, 60 is there in 30 to 60 because I have written it as less than equal to 60. So 60 is there in my second category. If I change this in 61, if I change this age to 61, you can see it will be more than 60. You can change it and you can see whether it is like changing. Yes, we have shared it. We have shared this data set with you people. We will share the PowerPoint presentations. We will share the video recordings also of this session, because those of you who could not attend, or you had to go somewhere else, or maybe if you want to revise, we will share everything with you people. Slides, recordings, data set, questions, template, everything. Don't worry for that. And we have given, I think, few participants requested for recording from their own end also. We have permitted that also. If you want to record from your end, okay. So in which platform? meritindia.org. I think you all are enrolled for that course. You will receive videos to be uploaded in group also in the same day. So today we'll be able to do by 9 or 9:30 today itself, because it takes some time. So we'll share the video also. So where is the data sheet available? We have shared it over the mail. We have posted it in the group, in the Google Drive. We have shared the drive link with you people, and whatever like I'm showing it, it is available there.
Start karo.
So yes, now we are going to the breakout room. So all of you, please, there will be mentors from AIMS Patna and the other institutes who are our like team, because Merit India is a team as such, and all these activities which you have seen here, now it's your time to perform. So you have to show and run the commands in the breakout room. So before you start, all of you, it is requested from all the facilitators and mentors, kindly ensure that the JAMOVI should be installed in their PC.